familiar with some of those blood disorders. So this is the point that we left off on Thursday, where we had looked at the red blood cell, its importance in carrying oxygen, and why that's important, because we've got to get that oxygen to the tissues so that the cell can use the oxygen. Of course, we've got to get the CO2, which is one of the waste, back out. Sometimes the CO2 can travel on a red blood cell, but for the most part, it's going to be dissolved. Do you guys remember how the red blood cell made that enzyme? Okay? And it's going to travel dissolved in the blood back to the lungs. And then we got to the point where after the red blood cell had served its lifespan, those red blood cells, they kind of get, worn out as they travel around, because they're doing that like once every minute. So in the spleen, you remember, the reticular fibers allowed it to get caught, and we could now break it down. And we either return parts to the body, or some of it becomes part of our waste. So that was the point we had left off on Thursday. The other part about our red blood cells, and we kind of looked at this and the couple of erythrocyte disorders that I mentioned. One of the things about the red blood cells, they help us know blood type. And with our blood types, this is extremely important to know, especially if it ever comes to a time of needing a blood transfusion. Before we knew about blood type and other things that are in the blood, if a person was given a blood transfusion, they could have been given wrong blood and they died, okay? And it's a situation that as time has moved forward, we've learned a whole lot more. We can now type that blood. Some of us know our blood type, okay? Unfortunately, I'm not one. And, at the time of like a severe trauma event or something, hopefully the person that's going to be given the blood to type it is going to get it right, so that when they try to give you some blood, they're going to give you the right blood, okay? Doesn't say mistakes don't happen, because they do. The blood groups are known as A, B, and O. Under these, okay, the way that we determine what it is, on the membrane of the red blood cell, on that plasma membrane, it is going to contain some glycoproteins, glycolipids. We're going to see a chain coming off of that red blood cell plasma membrane. Can't remember if I've got a picture. And no. So when you think about the red blood cell, the plasma membrane, and once again, it's a bilayer of those phospholipids. Do you guys remember how you could have a carbohydrate, I can't draw my card, carbohydrate chain coming off of it? In these blood groups, A, B, and O, each one has a specific chain. And that is going to be what helps them determine, are you A, B, O? So what we end up having, okay, we're gonna have them be termed antigens and then antibodies. This is what will happen. For example, if you're given the wrong blood. Okay? Let's say that you are blood type A. Okay? And we'll get to the negative and the positive in a second. Okay? Now, let's say that you are blood type A. So, on your red blood cell, let's say that is what identifies you as blood type A. Let's say that you are B. This might be what identifies you as the B. If you are AB, you've got both. Are you kind of following me? All right. And then, if you're O, all right. Now, that would be the antigen. Okay? So, on that red blood cell, it is what helps your body detect that that is your cell. Do not attack it. When your body tries to attack one of your own cells, we know that as autoimmune. And what that means is your body would have developed an antibody to it. Okay? So, by having a way for your body to identify it, it doesn't want to do anything to that red blood cell. Let it just go do its job. Now, in the case of something going wrong, and because our body, all right, would have the ability to detect that and get our immune system involved, all right, because what does it want to do? If you're given something, I shouldn't say given, if your body encounters something that is foreign, what does the body want to do?
Attack it.
Attack it. Okay? It wants to try to neutralize it. It wants to try to eradicate what has invaded you. All right? So, a person who would have A blood in their plasma, which is where you would find an antibody, okay? They would be carrying this one. So that person who has blood type A, this antibody, would it attach to it? No. Because the body has recognized that that red blood cell belongs there. But what would it attach to if it encountered it?
The other blood?
Okay? Because what up there looks like this could attach to?
Any of them?
Mm-mm.
Just the B?
It would attach to B, and it would have the ability to attach to A, B.
Not the O?
Not the O doesn't have anything.
Oh, that's why that's the universal donor.
Because there's nothing that an antibody in the blood going to attach to? That's my antibody. This is my antigen. So let's say the person with B blood. All right? Well, their antibody would look like this that they have developed. Because that would attach to what? A. If we have the person who is O blood, for O, technically, they shouldn't have any antibodies, okay? For AB, the person has developed both. So, O, yes, would be the one that we think of as the universal donor. AB is a universal recipient. Now, if someone, for example, with A is given B, B given A, all right, what happens is if they are A and they're given B, this attaches here, and because I'll have a whole bunch of these, they will attach to all the B's. Their goal is trying to eradicate them, and because they're attaching to them, they begin to create clumps, which is agglutination. All right? So, when we can get the situation let's say person is type A, but they're given type B. Okay? Their antibodies attach, and because there will be these identifiers all over the plasma membrane, antibodies begin to stick together. And it causes those B cells to be clumpy. Now, let's think about this for a second. Is my blood supposed to clump?
Sometimes. No.
Oh,
No,
my
not
God.
when you're like clotting. Yeah.
Huh?
When you're clotting, isn't it supposed to clump at a clot?
Well, I'm talking about right now, not in a position where anything's been breached.
Okay.
The clotting would occur. Now, if a clot occurs in a vein that hasn't been breached, that's a blood clot. That's not good. Okay? Under normal conditions, blood flowing freely through the vessels. We don't want clumping. Okay? You want the clumping to occur at a time of a breach. All right? If it occurs any other time, it's a blockage. That's not good. Okay? If you've known anybody who's ever had a blood clot. So, no, we don't want the clumping. All right? We want the blood moving freely. So, if that antigen gets attached with antibodies, they agglutinate, which will now block our...
So that one is A and B. And
blood vessels. So, if we end up with a mismatch, what will begin to happen? As those red blood cells agglutinate, clump, they start off by blocking small vessels, which is going to be our capillaries. And if that